This is the notes for 4.2, fractions as decimals. Okay, we have 4 vocabulary here that we're going to highlight. The first one is rational numbers, is any number that can be written as the quotient of 2 integers. Okay, so rational being a fraction where I do not divide by 0. Okay, it can either end or repeat. Okay, so as long as it's not pi or the square root of something where the decimal does not stop or does not repeat, those are going to be rational numbers. So our example was a half, something over 99, 0.2. All of these decimals either stop or repeat. Irrational then is a number that cannot be written as the quotient of 2 integers. Okay, so it never ends and it never shows a repeating pattern. So irrational are all these things we've been approximating. So about 1 point something times 1 point something would get me close to 2, but I can't take a whole number times a whole number, so this decimal is never going to stop, never going to repeat. That's irrational. Okay. Also, within our category of rational, when it either stops or repeats, the terminating is for the one that ends, and then the repeating is where there's a pattern that repeats forever. Okay, so the note that I'm going to add myself, the terminator, right? Terminating decimals are the ones that stop. So for example, 0.5 stops. But the repeating are the ones that go on forever. So 0.737373, we would write that as 0.73 with that bar on top. That shows 737373 over and over and over again. Okay? If I cannot write it as either one of these two though, that's considered irrational. So pi, or anything that's approximately something with a decimal that doesn't stop, doesn't repeat, that's irrational. Okay, so on our number line today, we can put irrational and rational numbers. These are just approximations. Okay, but we're going to focus in on, within our rational numbers, is it stopping or is it repeating? Okay, so in your examples, we have those 3. We're going to practice the first 2 with long division, just so you can see where they're coming from. Okay, I would try that same thing today on the homework, but then we can put them in our calculator to check them. So let's start with 8/9. Okay, so if I have the fraction 8 divided by 9, 8 would go on the inside, and then we're dividing by 9 on the outside. 9 cannot go into 8, so I'd put a 0. Since this is a whole number 8, my decimal would appear after 8. And then I can add as many zeros as I'd like after that whole number. So it could be $8, it could be 8 with as many zeros as I want back here. How much does 9 go into 80? Well, 9 times 9 is 81, so I'm a little bit short. I'm thinking 9 times 8 is 72. So I'm going to subtract 72 from 80. That leaves me with 8. I cannot have a remainder, so I'm just going to carry down another 0. 9 times 8 is 72. That leaves me with 8. Hopefully we're starting to see a pattern here, right? Every time I put 9 into 80, I could do 9 times 8 is 72, but that would leave me with a remainder of 8. I'm going to keep getting that same remainder, so it doesn't matter how many zeros I pull down. This is going to be the same number over and over and over again. Okay. The part that tricks some people is in their calculator. When they do 8 divided by 9, they see this 9 at the end, and they think they have to write down all of these 8s and then a 9. Okay? Think about it. Is there any way that this pattern could ever change? In order to get 9 times 9 is 81. I will never get to 81. I'm going to keep getting over and over 80, 80, 80, 80, 80. Okay, so what my calculator did was there was an 8 followed by another 8, so it rounded that 8 up. So this is an 8 with an 8 after it, so this is truly a repeating decimal. So in your notes, that's what we're going to write here. So 0.8, and it does go on forever, so I can use that bar above it. On my number line then, it's just an approximation. So it's close to 0.9, right, but not exactly. And then we also need to label this, remember, 8/9. Okay, so even though there was this 9 at the end, remember when we looked at our long division, it keeps going 8, 8, 8. It just rounded up that next 8. All I need to do is write 1 with that bar. Okay. All right, let's try another one here, just so you can see the difference. So 7/4, I would put 7 on the inside. divided by 4 on the outside. It doesn't matter which one's bigger. It's because the top of my fraction was 7, so I put that in the inside. 7 divided by 4 would go in once, and I would have 3 left over. I don't want a remainder, so I'm going to go and put a decimal there. I can add as many zeros as I'd like. So my answer is going to be 1 and then something left over. 7/4 is the same as 1 3/4 if I was to write it as a mixed number, so that makes sense. This should be 1 point something. I'm going to go ahead and bring down my next zero then. So 4 goes into 30 7 times. 7 times 4 is 28. That will leave me with 2. I'm going to go and bring down a 0. 4 goes into 20 5 times. And you see the difference of I'm left with nothing. So this is one that terminates, right? It stops at 1.75 versus this that was one that was repeating, right? Notice how over and over and over again, it doesn't matter how many times I did it, I kept getting left with an 8, an 8, an 8. I kept having to bring it down. If at any point you see a 0, that tells you this is terminating. My decimal is stopped, okay? And I don't have to do anything more to it after that. I don't have to add more zeros behind it. Okay, so in our notes, -7/4 was 1.75. It terminated, it stopped. We did have a negative sign out in front of it though. So on my number line, so -1, -1.1, -1.2, 0.3, 0.4, 0.5, 0.6, 0.7. We're looking right here, would be -$1.75. Okay, I can also look at the fraction we said. If I change that to a mixed number, was -1 3/4, I would actually take that as well in your test. So if you went backwards, -1, and then 3/4 would be I chopped this into 4 parts and 3 ways back. So there's -1 3/4. Okay. All right, the last two, we're going to go and put in our calculators. So -3/7, 3 divided by 7, is a very long decimal, but you see how there's a 4 in there twice, okay? And then there was a 2, and then there was an 8, followed by a 5, so it rounded that one up. So this is actually repeating. If you can write it as a fraction, remember we said it was rational, so this could be a repeating decimal, and it's -0.2428571. That whole thing repeats. Anything divided by 7 is very ugly. Okay, but if you did the long division, once I got to that 4, the entire thing would just repeat again and repeat again and repeat again. Okay, so this one's really long, so we're not going to show it with the long division on our paper. Okay, but just know when you start to see the same numbers happen again, they are repeating that whole thing. On my number line, here's -0.1, 0.2, 0.3, 0.4.